So good morning, everyone. Welcome to the EMCC session. My name is Andy Soldadic. I'm working for a Cisco partner, Nexi Consulting. I'm a Cisco certified instructor since '96, and I'm involved in development of Cisco training material. So I'm instructor and consultant, and this session is coming from the certification track. Among other things, it addresses the preparation to CCIE, where the new CCIE collaboration is based on version 9. Nowadays we are using 10. 10.5 is about to come out, so I will highlight the differences, which in this case, in this session, are very, very few. It's basically just LBM support that was added to Cisco EMCC in version 10. So we address both. If you do prepare for the CCIE, then of course everything that I talked to related to version 10 is not applicable to the CCIE exam, neither the written nor the lab exam. So what am I going to talk about? We'll do an introduction about EMCC, starting with a quick review of extension mobility, and then take it further to extension mobility cross clusters. The operation, how it works, what are the steps involved when you register with a remote cluster. Then talk a little bit about the components, more from a configuration perspective. So we want to have a look at all the elements that you need to configure to get this work. And then we talk about optional features, things that you may or may not use, which is PSTN access at the so-called visiting cluster, RSVP agents. Then I will talk about the changes in 10, so basically support for enhanced location, call it mission control. And finally, some considerations and screenshots on how to implement it. So introduction, before talking about extension mobility cross clusters, what is extension mobility? I assume you're all aware of it, but let's review real quick. We have the possibility that the user logs into a physical phone. The user is configured with a so-called device profile, so a logical phone configuration. And as soon as the user logs in successfully, this logical configuration is applied to the phone. So we can have our personal phone settings independent of the physical device, and I just go to any device, log in, and get my settings applied. This used to work only within a cluster, and with extension mobility cross clusters, we also have the possibility to use it in a multi-cluster environment. EMCC was introduced in version 8. There were a few changes in version 9, enhancements, and again, there is one more enhancement in version 10 regarding the call it mission control. So what we are really looking at is a user that can roam between clusters, log into a phone which is registered at the so-called visiting clusters. We will refer to this phone as the visiting phone. That's the visiting cluster. And the home cluster is where we want that user to register to. So the home cluster is where you configured the user profile, the settings of this user. And at the end, after login, what we want is that this phone is simply registered over there, as if it was never registered at the visiting cluster. That's the main goal, and that's the basic functionality. As I mentioned earlier, you can enable additional features, optional features, PSTN access, which simply means when I say this phone is registered over there, what would be my PSTN gateways? Of course, it would be a gateway of the home cluster. My phone is registered to the home cluster. It's not related anymore to the visiting cluster. If you do use the PSTN access at the visiting cluster, then you can use this gateway for PSTN access. And that is, for example, very important when we talk about emergency dialing, right? In case of emergency dialing, my physical location is here, so I want to use the local gateway to get out to the PSTN. But it's not only that. Maybe you simply want to use that gateway for all patterns, not only for emergency dialing, right? So that's one additional optional feature which you can selectively enable between a pair of clusters. And the other optional feature would be to use RSVP agents. So in terms of call it mission control, bandwidth management, you could involve RSVP agents for calls between this phone and any phones that are at the home cluster or that gateway of the home cluster. We'll talk about all of this during the session. So what are the requirements? When we think about it, the challenge, of course, is that we have the configuration residing at the home cluster, but the user logs into a phone at the visiting cluster. And by definition, these two won't know a lot about each other. You will not have the user IDs of the home cluster at the visiting cluster. So even the login process already needs these two clusters to interact with each other, to send the username and the password or the PIN that you entered here over to the other side to have it checked there. How does the visiting cluster know what is the home cluster? I can enable extension mobility not between two clusters, but in a multi-cluster environment with lots of clusters. So how do I find out what is the home cluster that I should send user IDs pins to? So, of course, when we talk about an exchange of pins and user IDs across the network, then this has to be secure, and it is. All cross-cluster communication in terms of management of the feature, in terms of bringing it to work, is secured using TLS, and you will have to exchange certificates and so on. Don't mix this up with secure phones. You know, secure signaling from the phone to its communication manager. SRTP between phones, which is possible. Support for secure EMCC calls was added in version 9. So that's another feature that you can use. But regardless whether you do that, regardless whether your cluster is in mixed mode, whether your phone is in authenticated or encrypted mode, the inter-cluster communication between the two clusters in terms of logging in, finding out the configuration to apply, all of that is always secure transmission between the two clusters. So one feature is we need to have the possibility to log in. Actually, it will be the standard extension mobility service that we use. There is no different service. And if the visiting cluster is configured for EMCC, then extension mobility will simply say, if I don't find the user locally, then let me check with my remote clusters. Let me try to find the user somewhere there. So it's the one and the same phone service for EM and EMCC. Cross-cluster security, talked about that. PSTN access that is suitable for the visiting phone. As mentioned, if we talk about the country where emergency dialing is simply required, then you will have to take care about it, that emergency calls do use the local gateway, so the gateway at the visiting cluster. There are countries where this is not required by law, where it's not even common that you use such solutions, and then you are free to choose. But in addition to that, let's not only focus on emergency dialing. You could say, in general, for some calls, for all calls, I want to use the PSTN gateway of the visiting cluster instead of using the home cluster's gateway, which would be the default behavior, to use the home cluster's gateway. And then support of call admission control. These two clusters can be, or most likely will be, separated by a WAN network. So how do we handle call admission control in between? Standard location call admission control is not supported. You cannot do call admission control using the normal location feature. If you're familiar with enhanced location call admission control introduced in version 9, where you have an LBM network, this is supported since version 10. Actually, that was the enhancement done in version 10 to EMCC, that it supports an LBM network. But if you do not have an LBM network, location bandwidth management, and enhanced location call admission control, then you do have one option for call admission control between the clusters, and that is RSVP agents. You can use RSVP agents. And the difference to a standard RSVP agent deployment is simply, usually RSVP agents are for calls within a cluster. So I would have a phone in one cluster. It has a connection to one RSVP agent. That one has a connection to another RSVP agent, and that second RSVP agent has the connection to the second phone. So you split the RTP stream from a direct communication between two phones to a 3-call leg model. And the middle call leg between the two RSVP agents, and only that one, supports call admission control based on RSVP. So these agents are iOS routers running RSVP. That is supported from the beginning, since version 8. As mentioned, since 10, we also have support for enhanced location CAC. So when we look at the challenge and if we think about what do we need, what are the components that we need to bring together to allow a remote phone to register locally, well, then we will have some information that resides at the home cluster and other information that is only available at the visiting cluster. So at the home cluster, you have the end user ID, the username, ID, password, PIN, locale, certain settings that are simply configured at the home cluster of this user. You will configure a user device profile. This doesn't really differ from standard extension mobility. You would do exactly the same on normal extension mobility, just that there is one more setting. In this case, you have a kind of device level calling search space in case of EMCC, which you wouldn't have in case of standard extension mobility. How many of you are well familiar with extension mobility? Okay, good, very good. So I hope you all agree in extension mobility, you cannot update the device level calling search space, right? The user profile only updates the line calling search space, but not the device calling search space. That is different here, simply because there is no phone to actually update, but we have to apply a device level calling search space to a virtual phone, because at the home cluster, the phone doesn't exist. There are some templates, and we are building the configuration of that phone as the user logs in. So at the device profile, you have your lines, speed dials, features, same as you do in EM, with that one difference that you can configure the EMCC device level calling search space. The dial plan, of course, resides at the home cluster, because by default, all the incoming calls or the calls you generate from the phone are processed at the home cluster. And we have the possibility to send it over to the visiting cluster. So basically, the first decision for the call routing is always done at the home cluster, and it may use a local one. It may go to the visiting cluster for PSTN access, which also means class of service, your PSTN access codes, the way how you dial, this is all simply configured at the home cluster. And that's also the idea, that the end user doesn't have to adapt. I'm from Europe, so we have a totally different PSTN access numbering scheme. When you use a 9 for PSTN access, we have a 0. Your national 1 in the NANP would be a 0 in my country. So it differs. And of course, we don't want to bother the user in case of extension mobility, as well as in extension mobility cross clusters, with these details. If I am based in Europe and I log into a phone here, even if it's a different cluster, I want to be able to use my home dial rules. So I will dial as home. And then you have to take care about the rest with digit manipulation. I did a session on ILS and global dial plan replication on Tuesday. In that one, I did a review of globalized call routing. It would be nice to be able to do that here as well, but I'm afraid there is not enough time to go into all details here. But when you do extension mobility, device mobility, actually no matter which feature in an international deployment, where you have different PSTN numbering plans, then I would highly recommend to go globalized, do globalized call routing, which simply means that ingress, whenever you receive a call in Communications Manager, you blow up the numbers to plus E164 format, and only at the egress device you localize it based on the needs of the egress device, trunk, gateway, whatever it is. This is also applicable here. It was already applicable to extension mobility. If you allowed users within one cluster to roam between different countries. Now when we talk about extension mobility cross clusters, I would say it's much more likely that this will happen in that enterprise. So if you do not yet have a globalized call routing deployment, consider it. There are lots of advantages, especially with roaming features. And so it also plays very well together with device mobility, extension mobility, EMCC, even unified mobility, simplified. You will see later on examples that the digit manipulation that you have to do on EMCC, it will be easier if you're globalized. I'm not saying it's not possible without, but it will be simpler, again, in an international deployment. Okay, so let me move on here. Home cluster. I talked about the dial plan a little bit more later. Registration information. So where is this phone supposed to register? We have multiple call managers. In our cluster, we have a unified CM group that we want to apply to a phone. That's how we usually set up a phone. Via the device pool, we'll tell the phone what is your primary, secondary server to register with. And that's the same here. We need to tell that phone what are your servers. At the visiting cluster, the information that resides there, well, first of all, is everything that relates to the phone itself. The phone model, The protocol the phone uses, is it SIP, skinny, if it is a phone that supports both. The MAC address, so our identifier within the configuration database. Yeah, more or less that's it. We will talk about more like locales and so on later on. Local resources, as I mentioned, that's optional. You may use a local RSVP agent, because if we do RSVP in EMCC, of course the idea is that we use one RSVP agent of the home cluster and the other one of the visiting cluster. So all of a sudden, that phone that used to be at the visiting cluster but is now registered at the home cluster needs access to a device over there. So if you think about, this slide is called challenges. I have a media resource group list at the phone, right? At the home cluster. That one gives me access, let's say, to a conference bridge, which is always local. A conference bridge can never be allocated from the visiting cluster. But in this special case, when doing RSVP agents, all of a sudden that phone should allocate the media resource, the RSVP agent, of the visiting cluster. So you see there are challenges here. What media resource group list do we use? Can I configure a media resource group list at the home cluster to include a resource of the visiting cluster? Of course I can't, but that's what we need. That phone wants to allocate a resource of the visiting cluster. So these are the challenges that we face. And finally, what we, of course, utilize from the visiting cluster is everything that has to do with the basic IP network services. Sure, the phone is physically located at the visiting cluster, DHCP, TFTP, DNS, if used, all of that has to be provided in the visiting cluster. No doubts about that. So at a very high level, when looking to the solution, what we will have is we have the visiting clusters, communication manager, configuration database, simply representing the cluster, the visiting phone itself, and at the home cluster, there will be a virtual device entity. So from a configuration perspective, of course, we also need to represent that phone. But it's, of course, dynamic, because if nobody is logged in here, then this phone, this MAC address, this identifier of the phone must not exist over there. But it has to be dynamically added as soon as we see a login here, a successful one. So what will happen is that when you log in here, all the data that we need over there to build a configuration file for this phone will be sent from the visiting cluster to the home cluster. Primarily the MAC address, and as I mentioned earlier, phone model, protocol, and so on. At the end, we need to have an entry here which simply allows this phone to register. And once that is done, once that information has been sent over there, then the phone can register, which simply means somehow we will have to tell this phone, which currently is registered to the visiting cluster, now after your login was successful and after we sent the information over there and the configuration file was prepared over there, go there, register there, not locally anymore. So, you know, tiny little things. This is also supposed to be a CCIE preparation. If you think about the written exam, for example, I could think of lots of questions asking for details. Where is the actual configuration residing, here or here? And you will see later on as we walk through the process, of course, we have to have two configuration files. The local DHCP server here, option 150, directs me to the local TFTP config. But what will not happen is that this cluster sends the full phone configuration to here, and you have the full config at the visiting cluster. Instead, you will have the full config over there, so that cluster is ready to accept the registration, but the phone has to pull the config from over there. And what will happen is that the visiting cluster will create a so-called mini config file, telling this phone, I want you to register elsewhere, go there. And it's not only registration, but in fact, to be more precise, it's pull your config from elsewhere, pull it from there. So we are redirecting this phone to the TFTP server from the home cluster. And now the phone will fetch its full config file. At the visiting cluster, you only have a mini config file that more or less just says, go there with your TFTP request. Okay, some release information. So as I mentioned, introduced in version 8. In version 9, support for secure calls was added. In general, Communications Manager version 9 added improvements in terms of regions. You can now configure a preference list, an audio codec preference list, right? That was a new feature added in version 9. What is that about? Because it somehow also applies to EMCC, but you will see that EMCC has its own region configuration, like it had in version 8. So audio codec preference lists have a simple functionality. Before they were added, all you were able to do in a region was you were able to set the maximum audio bitrate of the codec, right? 64 kilobit per second. And then Communications Manager decided, should I use G711 or G722, right? If both endpoints supported G722, that's what you got, because it's supposed to be better. You didn't have control. You were only able to set the limit, but you were not able to say, this is the codec that I prefer. Think about iOS, voice class codec. You can have your preference list there. And the same was added in Communications Manager version 9. Regions now can be configured with audio codec preference lists, and they also apply to EMCC. However, they had to be explicitly added to EMCC. Why? Because EMCC phones do not use the default regions. For EMCC phones, we have a separate configuration of regions that applies to all EMCC phones. So the standard regions of the device pool, they are ignored. And that's why this was not only added in general, but it had to be added specifically with new menu items also to the EMCC feature, which was done in version 9, along with support for secure calls. Communication Manager 10, as I already mentioned, adds support for enhanced location CAC. How many of you have practical experience with ELCAC? Okay, not that many. That's a cool feature. I should say it's more than cool. It's really great. Have a look at it. Basically, what it allows you to do is you can have call admission control totally different than you did before. In the old days, you were used to have a location at the device, right? And now you were able to say how many calls, how much bandwidth can I consume for calls coming in, going out of a location. Period, right? That was it. Did calls within a location count to that limit? No, not at all. With ELCAC, what you do is you have locations and you have links between locations, and you can configure the links and the locations with bandwidth limits, and you can have locations that are not having any endpoints in it. So you configure a location, but there are no endpoints. Why would you do that? Well, because the idea with locations and links is that you create a model of your network, of your physical network, of your path, of your links. So I can say I have different ways to get here or there. And the really cool thing about it, this would already be nice, but the really cool thing about it is it works across clusters. So you can have, or each cluster can have a view of the overall topology of the so-called LBM network, Location Bandwidth Management Network. And if you place a call from one phone to a phone located in a different cluster, the local communication manager knows what is the source location, what is the destination location, what is the effective path, more or less the shortest path based on weights that you configure, and do I have bandwidth between these two along that path? That gives you so much more flexibility in terms of bandwidth management. If you deal with large deployments and you do use call admission control, location-based call admission control, I'm sure that you faced some challenges on how can I configure it to really get what I want, right? Hub and spoke models merged with partial full mesh and so on. You were always in trouble. It was very difficult, not to say for some cases impossible, to reflect what you wanted to achieve by the location configuration feature. With LBM, that's solved. So enough about that. Sorry for the detour, but I think it's very important, especially in conjunction with EMCC. And that was the feature that was added in version 10 to EMCC, that you do have support for the LBM network now, for enhanced location CAC. Again, if you have large deployments with call admission control, check out ELCAC, Enhanced Location CAC. Back to EMCC. The login process looked at from a very high level. The user of the home cluster logs into a phone at the visiting cluster. Of course, at the phone where you log in, EM has to be enabled. and this cluster must participate in EMCC with other clusters. So if the visiting cluster doesn't find the logged in user, the visiting cluster will say, okay, I'm configured to do EMCC to several peers, and it will check, query the other clusters. All clusters are candidates to home that user. Do you know that user ID? So we are sending the user information, the login information, to all the partner clusters, all those that participate in EMCC, and we ask, does anybody know this user? So hopefully one cluster responds back, yes, I do. And that way you find out what is your home cluster. And what then will happen is that the home cluster builds a temporary device, so simply creates a new phone based on certain templates and based on the information that was sent from the visiting cluster to the home cluster, builds the config file. Once the login was successful, the home cluster directs the phone to the TFTP server. Sorry, the visiting cluster directs the phone to the TFTP server of the home cluster. The phone registers with the home cluster after, of course, downloading the config file from there. So that's the high-level login process. Now let's dig a little bit deeper. Let's have a look at it step by step. So the user logs into this phone. The phone has to be enabled with extension mobility service. There is no different service for EMCC. It's simply the extension mobility service. Types in user ID, provides the PIN, and the cluster now here will simply search for the visiting cluster, as already for the home cluster, as already described. If there are multiple candidates, we check all of them. So there is a question. Yeah, let's accept questions during the presentation. Yeah. If that user ID exists on both the same way because you go to the same LDAP directory, then you are in trouble because there is no clear identification of where you are. So actually, we could talk about that a little bit later on potential ways on how to solve it, but generally spoken, absolutely true. The user ID must reside on a single cluster. Yeah, let's leave it like that. As said, there are also version-specific stuff, so we can talk about that later. For now, let me move on here. So I need to find out what is my home cluster by simply querying, does anybody know that user? We get back the information, yes, I have that user, ID and PIN are correct. And now the visiting cluster communication manager gets the device details, device protocol, phone model, MAC address, that's basically it, and provides all that information to that home cluster, including the PIN now. As mentioned, all communication between the clusters is secure, so no worries about pins being exchanged and so on. That's TLS-based. Now at the home cluster, the user is authenticated, so we check user ID and PIN. Do we know that? And if so, is this user allowed to use EMCC? At the end user configuration page, there is a checkbox, EMCC. So you have to explicitly allow a user to be an EMCC user, to be allowed to do EMCC cross-cluster logins. After successful authentication, the phone record is created. We know the phone model, we know the MAC address, we know the protocol, we know the end user's device profile, which is stored at the home cluster. So all of this is now put together to a phone configuration entry, so we simply add that phone to the database, and then after the config file is created, the home cluster will inform the visiting cluster of its IP address, of the IP address of the TFTP server. So it's not about the registration itself, that's your primary, secondary communication manager where the phone should register to, but it's the TFTP server address. With that information, the visiting cluster will modify its existing device record. You know, that phone was registered or still is registered with the visiting cluster. It's simply a local phone where a user went to and logged in. So that config is now modified, and as I mentioned earlier, it's replaced by a so-called mini config file. That mini config file basically has the TFTP server address of the home cluster in it. So the local config file changed. Of course, the phone has no clue about that because it didn't reset. It's still registered, right? So it's not enough to just update that config, but of course we have to force the phone to download that configuration. And that's basically what happens next. The phone at the visiting cluster is reset. It pulls that config file. The config file tells the phone, fetch your config from elsewhere. Go to that TFTP server. So the phone will do that, downloads its new configuration file, and is now able to register. Before it will attempt the registration, what it also checks is the locale. So if the locale configured at the home cluster differs from the one that is currently active at the phone, it attempts to download the locale from the local TFTP server. So the locale is not downloaded from the home cluster, which simply means for you, if you deploy it and you want to support different locales, you have to make sure that the locales of the home cluster also exist at all potential visiting clusters. Otherwise, this will fail. Then the phone simply moves on with the locale it had before the registration at the visiting cluster. So that's simply try and error. If it doesn't work, then we use what we have. Otherwise, you will get the correct locale. And now the phone is really ready to register with the home cluster. And in the basic functionality, if you do not use local PSTN access, if you don't use RSVP agents, that's all that happens. The phone is now registered over there. There will be no further communication or involvement of the visiting cluster. We've done what we have to do. The phone is over there, cross-cluster registration. But on top of that, you could say, in some cases, for some features, for some dialed patterns, I want to use resources of the visiting cluster. Okay. Components. Geolocations. How many of you have experience with geolocations outside of EMCC? If you didn't use EMCC, did you ever touch geolocations? You're dealing with India? Oh, why that? So what are geolocations? Geolocations are a configuration element that is used for logical partitioning. And logical partitioning is a feature that simply allows us to configure communications manager in a way to comply with certain laws. And one example would be India, where you have restrictions on TIHO and what gateway you use. You must not use the IP path, so always the local gateway. And logical partitioning helps you on that. So geolocations initially were added for logical partitioning. They are now reused also for EMCC. So we are using a configuration element which was initially introduced for something else. I'm just pointing that out because when you search for geolocations documentation, very often you end up at logical partitioning. So you may get confused, why do I need logical partitioning for EMCC, or how does that play in here? And no, that's a different feature. It was the first feature using geolocations. Geolocations will help us in EMCC to select the so-called roaming device pool. And if you deal with mobility features, then again you have to be very careful. There is a feature called device mobility, and that one knows the concept of roaming device pools. There is a feature called extension mobility, and that one does not know the concept of roaming device pools. EMCC does. So we are talking about extension mobility across clusters, and we are using a feature that is not used by extension mobility, but by device mobility. What is the idea of roaming device pools? Well, in device mobility, I guess the name explains what that feature does. You have a device that you take with you and you go to a different site. Most likely not a physical phone, but a soft phone, I would assume, right? And as you moved elsewhere, you also want the configuration to be changed to reflect that you are located elsewhere. What does this apply to? Local route group feature. When I'm supposed to use a local route group, then if I move, let's say we talk about a cluster that involves Austria, where I'm coming from, and US, and I'm coming here with my soft phone, and I want to use a local gateway from here, now where I'm in the US, then of course certain things have to change. For example, the standard local route group in my device pool. And that's why my device, IP communicator, for example, needs to have a different device pool, a roaming device pool, when I'm going to a different site. What else should be changed? Well, think about if you have a policy where you say I'm using a high bandwidth codec at the local area network, but I want to use, let's say, G729 across the WAN. When I'm moving with a soft phone, let's say IP communicator, from Austria to here, and now I place a call to one of my buddies back in Vienna in Austria, then without device mobility, what would happen? I would use G711, G722, whatever the high bandwidth codec is, right? Because I would still be considered to be a phone in Vienna. Just my IP address changed, all the configuration remains the same. So that is taken care of by device mobility. I have a roaming device pool, that one has a different region, and therefore, if I'm now calling Vienna, it's a call from US to Vienna, and not Vienna to Vienna. Same with call admission control. What is my location? Right? That also needs to be updated when I'm roaming with a device, for example, with a soft phone. So that's the concept of a roaming device pool. And in EMCC, we also have that same concept. So the phone that is registering at the home cluster, it has a, let's say, default device pool that you configure when you add the so-called dummy devices. But once a user logs in, there will be a selection of a roaming device pool, which is optional. You may find one, you may not find one. If not, then you use whatever the template is, which on the other hand means it's the same for all phones. If you do find a roaming device pool, then the primary reason to do that in EMCC is that you want to have or want to set the so-called adjunct CSS. So I hope you remember the days where we had to use or where we used line and device calling search spaces in a multi-site environment, and not just use them, but use them in the correct way. The device calling search space had the idea to select the egress gateway. The line CSS was responsible to do class of service. All this was before version 7, right? Because with version 7, we got local route groups, so there was no need for a device-specific calling search space anymore, which would take care about the egress gateway selection. That was simply eliminated by local route groups. But if you were familiar with that, you had two calling search spaces you had to deal with and be aware of. There is a concatenation of the device level CSS, the line CSS. The partitions of the line CSS have priority over the device CSS. And now with EMCC, we add one more layer. You have three calling search spaces. You've got the device level CSS, the line CSS, and the so-called adjunct CSS, which is taken from the roaming device pool. And this calling search space will be very important when you look at emergency dialing in an international EMCC deployment. And maybe also, it can also help you if you want to use general PSTN access and you do not yet use the local route group feature. And you do not want to change everything to use local route groups in your home cluster, but you still want to be able to send EMCC users to the visiting cluster's PSTN gateway. Then the adjunct CSS is your friend. It can help you to achieve that. Okay? So, primary reason to have a roaming device pool is to be able to configure an adjunct CSS, which in other words means if there is no need to have an adjunct CSS because you already have local route groups, you don't have to manipulate the number and so on, then there is no need to have roaming device pools. Okay? That's the primary function to provide that adjunct CSS. When you deal with roaming device pools, when you see the need for them, then the way how it is selected is based on geolocations. In device mobility, you're selecting the roaming device pool based on the IP address of the phone, right? But that only works within a cluster. In EMCC, the selection of the roaming device pool is based on geolocations. So what are geolocations? It's simply a tag or multiple tags. You can configure every single phone with its geolocation, geographic location. This one is in Europe, Austria, Vienna. And actually, there are lots of fields. It follows a standard on the fields that you can use for it. And then you will use filters at the visiting and home clusters to say, what of these fields do I want to look at? And you also configure their roaming device pools with geolocation tags. So when the home cluster receives the registration of a phone, it's not only the phone model, the protocol, the MAC address that we receive, but we also receive the geolocation of the visiting phone. So the visiting cluster provides the home cluster with the geolocation, and that enables the home cluster to say, okay, I know you roamed to cluster Austria. Let me look up if I have a roaming device pool for you. And if I find one for that geolocation, then this device pool will be applied to the phone as it registers. This gives you, that device pool is configured with the adjunct CSS. That one is added to the line and device level CSS. And that gives you the possibility to have one more calling search space at the phone, depending on its location, depending on where the user logged in. And you will need that if you have different digit manipulation needs per visiting cluster. When I'm logging in, let's say here in the US, and I want to place an emergency call, I want to dial like I'm used to at home. 112, that's our emergency number. So as I'm registered here, as I'm registered back home, but I want to egress at the gateway here, the number will have to be changed to 911, right? But if I wouldn't log in here in the US, but I would log in UK, then 1112, well, maybe it's supported there, but maybe it's 999. So depending on where I'm logged in, the number that I dialed has to be changed differently. And you can solve that problem by adding that calling search space, which is simply depending on the visiting cluster. We go back to it in more details, but it's a rather complex concept, so I think if you hear it 2 or 3 times before we get to the actual example, it will help you a little bit to follow immediately once you see the example. Okay, so that's what geolocations are here for, to select a roaming device pool. The roaming device pool, in fact, is a normal device pool, right? It's just that this one was chosen to be the roaming device pool for a logged-in user based on the geolocation that was matched. And the way this works is, as I mentioned, that each device pool in your cluster is configured with the geolocations it should represent. The phone provides its geolocation information, or the visiting cluster provides that information to the home cluster, and now you can match and check which one you want to apply. So in this example, we have the home cluster here. So the home cluster is where I finally want to get registered, and we see 2 candidates where I can log in. So I can roam to San Jose or to UK and use EMCC. Let's start with the US example, the top example. So that's my visiting phone. I log into that one. The phone itself, that's a phone configuration setting, has a geolocation. US, California, San Jose, Tasman 100. At the home cluster, there is a EMCC geolocation filter applied. You can have, I don't know, by far more than 10 fields here at the geolocation. Geolocation has lots of information that you could configure. At the home cluster, you configure a geolocation filter where you say, out of all the fields that are potentially configured at that phone, which are the ones that I want to look at? Which ones are relevant to me? Well, in its country, A1 and A3, which in this case would be the first 3 here, US, California, and San Jose. Which means out of the configured geolocation, this is what I will look at. This is what I consider when trying to find a match. At my device pools, I created a device pool for the San Jose cluster, another one for the UK cluster. I will now configure the geolocation that it should serve, which means after applying this filter to the actual geolocation of the phone, this is what I get, and I check, do I find a match in one of my device pools? Yes, I do. So the roaming device pool is device pool for San Jose cluster, if I logged in there. If I log in at this phone located in London, then again, this is the phone's geolocation, including street address. I'm only interested in the first three, which is UK, London, London. And again, this could be a nice CCIE level question. Do you find a match in this device pool? It says UK only. So we are not matching all three of them. No, the question is what has to match where? What do we look at? And in fact, when trying to find the roaming device pool, every field that is set at the device pool has to match what we received. We didn't set A1 and A3 here at the device pool, which means we don't have to match it. So yes, you do have a match in this case. What we get after applying the filter to the phone's geolocation are these three, but the device pool says, well, as long as the country is UK, I'm good with it. You know, we could look at it from a different perspective. We could say the lookup says, I need to find these three in a device pool to have a match. It's the other way around, okay? As said, on CCIE exams, on the written CCIE exam, that could be a nasty question, right? Do you find a match here, yes or no? And you have to know how it's matched. Okay, dummy EMCC devices. So as already mentioned, when doing EMCC, one configuration element is a EMCC device, dummy devices. You will add those using the bulk administration tool, and they are more or less placeholders for actual phone configurations once a user logs in. And the number of dummy devices that you add via the BAT tool limits the number of concurrent EMCC logins. So you're really preparing a configuration, a phone configuration slot. At the moment, as long as nobody is logged in, it's not in use, the phone doesn't exist, but it will be utilized once you log in, and then it depends on the number of dummy devices that you added. As mentioned, done by bulk administration, and there is one, again, interesting piece here. When you add the dummy devices, you also associate a device pool with them. So why is that? I was just talking about geolocations and roaming device pools, so obviously the roaming device pool is applied to the phone. Why do we have to select the device pool when adding the dummy device? Well, because you probably do not find a match in here. It's not mandatory to find a roaming device pool. Think about it. If you don't have the need for an adjunct CSS, then maybe you're good with one and the same device pool for all phones that are registering at your home cluster. Then there is no need to have roaming device pools, right? So that's why we have the default device pool, just like you do in device mobility. The phone is configured with a device pool, and it may be modified with a roaming device pool if you find a match at login time. Okay. Certificate exchange. Communication between the clusters, as far as exchanging user IDs, configuration files, information, is always secured. Signaling between the two clusters, call signaling, is not secured by default, and therefore it's impossible to have SRTP in place between the phone and other phones, unless you would configure that. But by default, the security that you get is all the, let's say, call it management traffic, control traffic. That one is perfectly secured by TLS. And that's why it is mandatory to exchange certain certificates. As this is always secured, we need to be able to do TLS, and TLS needs to have something in common on both ends. Either you exchange certificates or you would have a shared password. On other features like ILS, you could choose to do either certificates or passwords. Here you can't. It's certificate-based. When you do EMCC, you have to exchange Tomcat and TFTP certificates across all clusters. So each cluster has to know these two certificates of all other clusters participating in that EMCC deployment. If you choose to use secure EMCC, which means also the endpoints, the phones, should be secure. I want to have an authenticated phone mode or an encrypted phone mode. I have mixed mode clusters on both ends. Then you also have to exchange the CAPF certificate. So it's TFTP, Tomcat, and if you use secure EMCC, also CAPF. How do you do that? How do you do certificate exchange? This could be a high number of clusters. So the operating system, GUI, has a bulk certificate management feature which simply means what? You go to one server, you export this server's certificate to an SFTP server, then you go to the next server, you export that certificate to the SFTP server, and you do that at all clusters. And you do that to the same directory, to the same SFTP server, and the export, or simply the feature, always shows you what are the current certificates in that directory. So once you exported the last one, you see all the certs in that directory, and then you click another button, which is Consolidate Certificates. Now they are all put into one single file, and now you go back to every single server to import them. I said server and not cluster. If you have a cluster and multiple communication managers, then what do you have to think about? Certificates, before 10.5, there are some changes in 10.5, but before 10.5, certificates are always per server, right? Does that mean that in each cluster you have to export more than one certificate? Well, let's again think about it. What type of certificates do we have to exchange? Tomcat. Do you need that one from the publisher and the subscriber? No, publisher only. It's the publishers only that exchange configuration database information. TFTP could be, you may run more than one TFTP server. So in this case, you would have to export each TFTP server's certificate if you configure EMCC to use more than one TFTP server. What about CAPF? Should also only run once in your cluster on the publisher. That's at least a recommendation. So other than in different features where we look at call control at the Cisco Call Manager feature service, where one cluster could talk to the other cluster to a number of servers because we are doing SIP, call control. Then you need to export every single server's call manager certificate. In this case, no worries, Tomcat, publisher only, TFTP, as many as you configure the EMCC feature to use, and CAPF, usually if you follow the guidelines, also just one. Okay? So maybe you see I'm pointing something out here which is not even that important to EMCC, but it's very important on other features. I've seen lots of deployments where let's say you do intercluster trunks via SIP. Your communication manager group tells you I'm allowed to use, let's say, 3 call manager servers on both ends. You do secure exchange. You want to use TLS. And you only exchange certificates of one server. As soon as you have the backup scenario that you use the secondary server and you miss the certificate, it won't work, right? Always consider backup situations. And at the trunk, you simply have a device pool, communication manager group, and that one decides which servers you're using. So maybe more or less to give you some relief here, it's not that critical. The TFTP server part is the one that you have to take care if you configure EMCC to use more than one TFTP server. Make sure that all of these certificates have been exchanged. Codec selection. In EMCC, the region that is applied to the device pool or the roaming device pool is not applicable, but you're configuring codecs in general for the EMCC feature. So in EMCC, you have a section where you configure the codecs, and you have 3 configuration options: audio maximum bitrate, maximum video call bitrate, and the codec preference list. Since version 9, of course, only. It didn't exist in version 8. And that should be configured with identical values in all participating clusters. So you should decide for EMCC phones what is the codec that I use in general. So this is really an EMCC config, applies to all phones that register at this cluster, should be the same on all clusters. The region of your device pool is ignored. Optional features, an overview: RSVP agents, one optional feature, and the other one is the local PSTN access. So RSVP agent, they were much more important in version 8 because at that time we didn't have support for LBM, or actually also in version 9. The standard location call admission control does not apply to EMCC. So if you wanted to have call admission control for remotely registered phones, then your only option was to use RSVP agents. That changed with version 10, where support for enhanced location CAC was also added to the EMCC feature. So that's one feature, and the other one is to use local gateways for PSTN access. And whenever you do that, either for emergency dialing only and or for general PSTN access, then you most likely have to deal with the adjunct CSS, at least in an international deployment. So RSVP agents, and before I show how it works in EMCC, let's just quickly recap how would that work within a cluster. Let's assume, just forget that cluster, it doesn't exist. We have one phone, we have another phone, we have this cluster. If this phone places a call to this phone, what happens? Communications manager will check what is the location of this phone, what is the location of this phone, and is the location configuration set in a way that it says, between these two locations, use RSVP. If so, then the media resource group list of this phone will be used to find this phone's RSVP agent, which is an iOS router. In fact, it's a kind of MTP. And this phone's media resource group list will be used to find out this phone's RSVP agent. And if these two agents are different ones, if they would be in the same media resource group list, then effectively you will not get RSVP, or maybe between the same device, so it won't do anything. But of course, the idea is that this phone is located at one site, this is at another site. You use a local router, and in between these two, we have an IP WAN. And now what will happen is that the RTP stream is split into three segments. We have a stream coming from here to here, and then from here to here. That includes modification of the outer IP address, of the IP header. So it's really, that's why I said it's an MTP. You're terminating the RTP stream here, and then you take the RTP payload and put it into a new IP packet. This is the source, this is the destination. And then you repackage again, this is the source, this is the destination. So you really have three separate RTP legs. And to the middle leg only, call admission control will apply by using RSVP. So these two routers are configured to use RSVP at that outbound interface. Hopefully the IP network in between is RSVP enabled to have full benefit of RSVP. And then you've got the resource reservation protocol, call admission control CAC for this call leg. That's how it usually works within a cluster. Now we want to do the same for EMCC phones. So this time, the phone that we have here is a visiting phone. It's usually registered at the visiting cluster. After the user logged in, the phone registers at the home cluster, right? Now, and it has a device pool here, either a roaming device pool or the default device pool that you apply to the dummy devices. If the device pool of this phone and the device pool of this phone in this cluster, totally forget the visiting cluster. If this cluster decides between these two phones I have to use RSVP, then we will use the media resource group list of this phone to allocate this RSVP agent. But of course, the other RSVP agent is under control of the visiting cluster. So what will happen is that this cluster says, oh, hold on, the second phone involved in the call is an EMCC phone. It registered as a guest from another cluster. It's a visiting phone. So it doesn't help if I'm allocating one of my routers, because of course this router should be as close as possible to the phone. We want to do RSVP over the WAN, so we need a device located at this site. And therefore, I will tell the visiting cluster, hey, there is a phone that used to be registered with you. Now it's registered with me based on EMCC, and that one needs one of your local RSVP agents. And the way to find out which one to use, that's a cluster. It can also be a multi-site deployment. So this phone is in one site at that cluster. This is in a different one. I want to get different RSVP agents in that case. I always want to have one of the local site. So how can this cluster find out which RSVP agent to allocate? Well, how do we usually do it? We look at the media resource group list. This cluster here knows that currently this phone is registered over there. I changed the config file to a mini config file that says, go to that TFTP server over there. But of course, the cluster still remembers the initial configuration. It has to. When you log out, the phone has to be able to re-register locally, right? So it knows what is the media resource group list of that phone in my cluster, within the visiting cluster. I still know that information. The home cluster told me you need an RSVP agent. Okay, let me use your media resource group list to find one. That's how you allocate it, and now you can do the call setup for these 3 legs. That's how RSVP agents work in EMCC, how you can have call admission control between the clusters if you're not using a Communication Manager version 10 and an LBM network, Location Bandwidth Management network between the 2 clusters. PSTN access. Call routing and path selection is initially always performed at the home cluster because that's where the phone is registered. So you have your line, your device calling search space, you've matched route patterns at the home cluster. And now it's, in addition, as I already mentioned, you could have the adjunct CSS if during login time we matched a roaming device pool. And if so, that roaming device pool may be configured with an adjunct CSS. So the actual phone config can include partitions coming from 3 different calling search spaces. But optional, maybe it is, maybe it's not. Regardless of the adjunct CSS, after the user at that phone dials a number, if that number matches a route pattern, the route pattern refers to a route list, then the question is, does this route list refer to a local route group? And by the way, since version 10, you can have multiple local route groups, but that's not really important now. But does it refer to a local route group? Or does it refer to a route group, so a configured route group? Or does it use the local route group feature? And only if the matched pattern ends up at the local route group, to be said, use the local route group, only then we will try to send the call to the visiting cluster and say, please, you do the job. You route it out through one of your gateways. Which simply means locally at the home cluster, you have to make sure that the dialed number ends up at the local route group. Let's assume you already have a local route group deployment. Well, there is nothing to do. Your home cluster will tell the visiting cluster, I want you to route the call. You're routing the call towards the visiting cluster. Let's follow on this idea. You already have local route groups. Maybe, at least for one pattern, you don't want it to be sent to the visiting cluster. Now you could use the adjunct CSS to say, I will make you match that pattern in a different partition. Identical pattern than you usually have at your cluster, but in a different partition. And that one does not end up at the local route group. I send you to a gateway directly, or to a route group, right? To a specific one in the route list. That way you can, in this case, prevent that some patterns are sent to the visiting cluster. But thinking about another use case, maybe more importantly, you do not have local route groups yet. It's a huge deployment. You didn't change to globalized call routing. You didn't change to local route groups. You accepted the fact that you have to use line and device calling search spaces to make it work, and it works well. Never touch a running system. That's what you have. But now you want to send some calls, for example, emergency dialing, maybe not because you want to, but because you have to the visiting cluster. Then again, you have to add a route pattern, which is the emergency number. Put it into a partition, which is part of the adjunct CSS. That one is listed first. It has priority over the line and device CSS. And that means your EMCC phone user finds a match in that pattern. So this one pattern refers to the local route group, and therefore the EMCC feature says, let me send the call to the visiting cluster. So you do not have to change your full deployment to using local route groups. You say, I just do it for particular numbers where I need it. Or the other way around, you have local route groups and you want to selectively prevent some numbers from going there. What you have to simply achieve is, if the number matches a pattern that ends up at the local route group, it will be routed to the visiting cluster. That's what you have to know. And the rest is what you make out of that. But one more time, you have that help by the adjunct CSS that you can say, and I can make you match a different pattern because you are a roaming phone. And even more than that, you can make me match a different pattern depending on the visiting cluster. I'm from Austria. If I log in here in the US, my roaming device pool, remember geolocations, roaming device pool selection, can have an adjunct CSS, which is different from the adjunct CSS in UK, if I would log in the UK cluster. Which means depending on where I'm logged in, you can catch my input, 112, my emergency number, differently, right? You can consider it differently or treat it differently. So that's really the whole idea here, that at the home cluster, you have the chance to make me match patterns differently than I would match them if I was a standard local phone, and even differently based on the visiting cluster where I'm physically located. And you know, the rest is dial plan stuff. This is the tool, the feature, and you can use it for whatever you like now. But of course, the use case would be emergency dialing or in general PSTN access to be sent there. The local route group makes the decision to send the call to the visiting cluster or not. Okay. Yeah, so far so good. So here we have it visualized. The final concatenated CSS that you have at your EMCC phone has the partitions coming from the device level. When we say the device level, which one? Well, it's EMCC, so there is no physical device configured at the home cluster, but the device profile. At that device profile, you can set the EMCC device level calling search space. There is a line CSS, again coming from the EM device profile. And there is the adjunct CSS, potentially, if there is a roaming device pool. All these are concatenated, so that's the resulting CSS, and it's shown in the order of priority. So the top ones have higher priority. Just a small reminder, priorities of partitions are only applicable if you have an equal match, right? If I have a more specific match down here, which means I'm matching all digits, and up here I match something, or I would match something that has, let's say, a bang sign, it's a variable length thing, or it has simply masks, X's in there, then of course I always match here. The top selection on matching a pattern is always best match. Only if you have multiple candidates, we look at the order of partitions. So when you design your dial plan here, let's say for emergency dialing, for PSTN access, you have to make sure that your adjunct CSS, if you want or need to use it, is the best match, best qualified match out of all, and then this fact that it has more priority will help you. If there is a better match elsewhere, then the adjunct CSS won't help you. So path selection is really done at the home cluster. If you end up at a local route group, then the call is sent to the visiting cluster. That's basically what you see on this slide, something I already explained. So let's have a look at an example. I'm at this visiting phone. I use NANP dial rule, so dial 91 and so on, a number that is going to the home cluster is interpreted there. This communication manager knows that I'm an EMCC phone. It simply uses this phone's concatenated calling search space, which may or may not include an adjunct CSS, to find the best qualified match, and if multiple equally qualified matches, the one of the top priority partition. And after that, after we match that route pattern, we have a look, does this route pattern refer to the standard local route group? And if yes, only in this case, this home cluster will send a zip invite over a Cisco EMCC zip trunk to the visiting cluster. So now the call is sent to here. This cluster now interprets the call, and actually at that trunk there is a calling search space, of course. And by default, that one would be used. You could say, I don't want to use the calling search space that is configured at that trunk, but I want to use the calling search space of that phone. Not the calling search space over there, but the calling search space this phone has in this cluster. Okay? That's a possibility based on a service parameter or advanced feature configuration, whether you want to use the trunk CSS or the phone CSS. What's the tricky part here in general? The trunk that you have here is not configured per home cluster, per partner cluster. But when you enable EMCC, you configure a single EMCC trunk, a template, and that one doesn't have a remote IP address. okay? Which means one and the same trunk configuration is used to each cluster on the other end. It's the same. That also means, and now I'm getting to digit manipulation, if I receive the call as dialed by the user, in this case using NAMP PSTN access rules with a 9 and a 1 and so on, that will work perfectly fine if the visiting cluster is also a member of the NAMP. If the visiting cluster is, let's say, in Europe, then the 9 wouldn't be right. 0 is our PSTN access code. Can you take care about the digit manipulation inbound here? You know, when you create the trunk, you can configure the trunk with inbound transformation CSSs. You can, but then you have to be sure that you can match each possible input. NAMP input, European input, I don't know what country. So lots of stuff, which simply brings me back to what I said earlier today, globalized call routing. If you use globalized call routing, then you would globalize 9151 and so on to plus E164 format at the home cluster as soon as the user dials it. You would match a translation pattern first. And then you have the number in plus E164 format. And if you do that consequently throughout your deployment, then it simply means that on those trunks, we are always in plus E164 format, which means on every trunk, you know exactly what to expect, what comes in. It's a normalized format. We always can refer to that one to do the local digit manipulation as needed. Okay? So, SIP invite is sent over here, and now depending on that configuration, you use either the trunk CSS or the phone CSS to find the gateway, the egress gateway, or to find the match locally. So that's how calls can be rerouted to the visiting cluster. The pattern you match at the home cluster must refer to a local route group feature. Otherwise, it will be routed locally. It's not sent to the visiting cluster. You have better control whether you match such a pattern by using the adjunct CSS. And one more thing now, if you do not use globalized call routing, or if we look at a number that theoretically couldn't be globalized, like an emergency number, I personally disagree with that. You could globalize it because you could say, in my enterprise, I have one number that represents emergency dialing by one number. But that's a different story. Now, let's assume I'm doing emergency dialing. So I dialed 112 here. I'm registered at the US cluster, right? Now, what you would want to do is, you would want to say at the home, I dial 112, I'm registered at my home cluster, but physically I'm in the US. So the visiting cluster is US, I'm registered at my cluster back home in Europe. I dial 112. I need to match a route pattern that refers to a local route group, and then I want to send it over to here. I need to change that number 112 to 911 before sending it out on the zip trunk, right? And if that was not US, but UK, then I want to change 112 to 999, which means depending on the visiting cluster, depending on the phone where I logged in, you need to modify the same number that I dial differently. Again, roaming device pool. You can identify by the geolocation that I roamed to the US. You can have a roaming device pool that says the adjunct CSS gives me access to a partition that says 112 is to be changed to 911. If I log into a UK phone, you give me a different adjunct CSS, so I'm matching pattern 1112, and this time the pattern is manipulated to 999. I hope you see the point of the adjunct CSS. You make me match the same pattern differently depending on the visiting cluster, and that gives you the chance to do the digit manipulation at the home cluster before you hit the EMCC trunk. And of course, there are different ways to do it. Another way would be that you configure EMCC trunk at this visiting cluster inbound, where you say, I may receive 999, I may receive 112, I may receive 911. Inbound, I simply match on all possible emergency patterns and I translate them to whatever I use locally. That would be a different way of doing it. But you know, emergency dialing here is just an example. You may have different needs. And the point is really, you have the chance to change numbers depending on the visiting cluster where you're going to by the adjunct CSS. There's a question back there. Yes? Pardon me, it's bypassing what? SME, Session Management Edition. Yes. So basically what you will do when you go from this trunk to here, it's really between these two. So when you do the EMCC login, the home cluster learns what is the IP address on the other end, and that's where I sent the call to. Okay. So we talked about that. Now, at the visiting cluster, after the call comes in, what if you would match a pattern here? We said I can use different calling search spaces. I can use the calling search space of that phone or of the trunk. That's simply a parameter where you can decide. What if you match a pattern in here now that refers to the local route group? Well, the same that we had in RSVP agents with the media resource group list. The visiting cluster still knows what was the phone's configuration, what is the device pool of this phone in my cluster. That device pool has a local route group set. So if I end up at a pattern that refers to the standard local route group, I simply use the local route group of that phone. Okay? Think about it, that involves certain things. I mean, it's not really highly important, but it also means that when the call is sent over here, there must be an additional information saying what was the phone. Right? What is the originating phone? But something we don't have to worry about. That's simply taken care of. Okay, so I already talked about emergency dialing when discussing PSTN access in general. So one more time as a recap, emergency calling. First of all, your pattern has to be matched, or you have to match a pattern that refers to the standard local route group. Otherwise, there is no redirection to the visiting cluster at all. If you need to manipulate the dialed emergency number to a different one, you can already do it at the home cluster, so at the source of that redirection, towards the visiting cluster, depending on what the visiting cluster is, based on the adjunct CSS. And that's really why the adjunct CSS is there, so you have that possibility. Okay, so spoke to all of this. Here is the example. I dial 911. I match a pattern here that refers to the local route group. So now I'm sending it across the trunk. In this case, I want to modify 911 to 999 because the visiting cluster is in UK. So I assume you have a roaming device pool here that identifies this phone to be a UK phone. That device pool has an adjunct CSS, which gives us access to a 911 pattern, and that pattern now is manipulated to 999 before it's sent out. Yes? Yeah, I'm no expert. I'm not even at professional level on UCCX, so it's hard for me to judge. But from all I know, I wouldn't see a reason why it wouldn't work. But don't take it as granted. I'm not deep enough in the UCCX area here to be able to answer the question. But generally, I think you know what you get here, right? You have a phone that after the login, you are registered over there. If that helps you or suits your needs, then it's good. But feel free to talk to me after the presentation. And, if you tell me a little bit about your deployment and how UCCX is integrated and how you do it, then I guess I will be able to help you. Okay? So RSVP agents, in more detail, they apply to calls between the visiting phone and calls placed to the home cluster. As the phone is at a different site, we want to have call admission control. You can use RSVP agents. Standard location CAC was not supported. Since version 10, LBM network enhanced location CAC would be an alternative to using RSVP agents. So in the visiting cluster, the RSVP agent is chosen based on the media resource group list of the visiting phone, how it looked like before there was a login. At the home cluster, of course, it's taken from the device pool that was applied to that phone. It's either the device pool that you added to the dummy device, or it's a roaming device pool if you do match a roaming device pool based on geolocations. So looks very, very loaded, but actually basically what really happens is the visiting phone, you place a call to the home phone or in the other direction. The home cluster says these two have locations. It's different locations, and I'm configured to use RSVP between these two locations. Usually I would use the local media resource group list of both to allocate a local RSVP agent, but hold on, one of the phone is an EMCC phone, so I will have to send that request to the visiting cluster. The visiting cluster uses the MRQL of that phone to find this RSVP agent, and all the rest is standard signaling in RSVP. We tell this agent, hey, I need you to be an MTP, act as an MTP for this stream and to this stream. Same over here. Once the RSVP reservation is successful between the two, all the call legs can be set up end-to-end. We have our RTP stream between the two phones, where from IP addressing perspective, it's from here to here, from here to here, from here to here. So it's repackaged. That much about RSVP. Now, what is different in version 10? As I mentioned, not too many things changed. It's really just that LBM networks are supported. Location bandwidth management, enhanced location CAC, was added in version 9 to Communications Manager, but at that time, you were not able to use it with EMCC. With version 10, EMCC simply also makes use of an LBM network. Again, if you do deploy call admission control in a complex environment, if you struggled at the moment on reflecting your needs with a standard location configuration, check out Enhanced Location CAC. It's really great, very flexible, and as I said, it works across clusters, and that's why we can simply utilize it here. So in terms of EMCC support and Enhanced Location CAC, it's very simple. If the EMCC trunk that you configure, one single trunk, which is a template used to all other clusters, if that trunk participates in the LBM network, which technically spoken means you assigned it to the shadow partition, then you will have LBM exchange. The clusters are in one and the same LBM network, and then your communication manager is aware about all the locations of its local cluster and all the other clusters that participate in the LBM network. And now you will have end-to-end Enhanced Location CAC based on these locations and links in between. There is the effective path. You have limits on links, on locations. You can really model your IP network. So you can truly reflect the actual path, and you can assign bandwidth limits based on that network model. Really cool if you do call admission control in complex environments. That was a really great enhancement in version 9. In version 10, it's implicitly used for EMCC if your trunk is in the shadow location, which simply means it is allowed to participate in the LBM network. And of course, you also have to join that LBM network at each cluster. So basically spoken, both clusters have to be in the same LBM network, and the trunk in between has to be enabled for Enhanced Location CAC. So some considerations on EMCC. You cannot have duplicate user IDs. Even if they would have different pins somewhere, no, you have to have a unique user ID, so it must exist just in one cluster, because that's how we find out what is your home cluster. The intercom feature is not supported by EMCC. You can do secure EMCC, which means you can have TLS signaling and SRTP support at the endpoint, at the phone for the calls. In that case, the CAPF certificates also have to be exchanged when you do the certificate exchange between the clusters. The visiting cluster has to be in mixed mode, and the visiting phone has to be in secure mode. And in addition, the home cluster has to be in mixed mode. And finally, as it was only introduced with release 9, support for secure EMCC, both clusters have to be of version 9 or higher. And actually, this should say secure EMCC, not supported on all phone models. Of course, you need a phone model that supports security. So that much about the concept, the theory. Now I have some screenshots on how to configure it, but basically that was everything on how it works and what you can use it for. Let me do a quick recap. So the phone can register at a different cluster. By default, everything would be taken care of at that home cluster. What you can do is you can use PSTN access of the visiting cluster. The way to enforce that is you have to match a pattern that refers to the local route group. Then the call gets sent to the visiting cluster. And in terms of call admission control, if there is an LBM network, then implicitly it's simply used. If not, you can choose to deploy RSVP agents, and then the visiting phone will allocate its agent from the visiting cluster. Nothing else would make sense. All the rest is controlled by the home cluster. What about other media resources? Conference bridges, annunciators, transcoders. They are always taken from the home cluster. The only media resource that you can pick from the visiting cluster is the RSVP agent in case of doing RSVP CAC. Everything else is definitely always controlled at the home cluster and allocated from the home cluster. Okay? So now let's have a look at the implementation procedure. You have to activate the required services. You have to create or configure the extension mobility IP phone service. It says EMCC here, but actually the service that you configure is the standard extension mobility service. You configure end users. You have to explicitly allow the users of EMCC. You configure extension mobility on physical phones. Again, that's allowing extension mobility at the phone, and it applies to both. You manage the certificates. You do the bulk certificate management by exporting all the individual certificates, consolidating them, and then importing them. You have to insert the bulk dummy devices, where you have a common device configuration toolset. You have to create a template. You have to finally insert the devices based on these two. You may want to use geolocations to be able to have a roaming device pool. If you do that, it's mandatory to configure the geolocation filter, even if then you don't use geolocations. But from configuration-wise, you have to configure a filter. And if you really want to use it, then of course you also have to apply geolocations to the endpoints, to the phones. That's done in the visiting cluster. And you will configure geolocation tags at your roaming device pools to match them. You configure that EMCC zip trunk. As I mentioned, it's a single trunk used to all destinations. If you choose to do digit manipulation at that trunk by incoming outbound transformation settings, which you can apply to a zip trunk, then be aware that it applies to all possible peer clusters. So if you would refer to numbers, you have to expect any possible format. Therefore, the idea here is, or the preferred option would be, that at the home cluster, you do the digit manipulation via the matched route pattern before you hit the trunk. And that can be done based on the adjunct CSS differently per destination cluster. You configure the EMCC intercluster service profile, and you configure the remote clusters, so which clusters should be allowed to participate in EMCC. So you activate the Cisco Extension Mobility service. You need the bulk provisioning service. You add the IP phone service, the standard extension mobility phone service to the phone, so you subscribe to that phone service at the phone. Which cluster are we talking about here? Visiting cluster or home cluster? That's the visiting cluster, right? I need to have the extension mobility service so I can log in. So we talk about the visiting phone and the visiting cluster configuration. In most cases, you will allow cross-cluster login anyway in both directions, right? Users from here are allowed to roam here and vice versa. The reason why I'm sometimes asking, where do you need it? As I mentioned, it's also CCIE preparation. In CCIE, there may be a requirement, say, do the minimum configuration to allow a user from here to log in there. And then if you enable it to be possible in both directions, then you failed because you configured more than was the minimum needed, right? So you really have to know, what do I need to be able to have a user logging in from here over there, right? And then you do some things here, some things there. If you say every user is allowed to log in everywhere, then you simply do everything everywhere. So start thinking, what do I have to do at what device or at what cluster? And this would be an example. At the physical phone, you only subscribe to the EM service wherever you log in, right? Okay, device profile for EMCC users. So you configure a device profile for that end user. Unfortunately, it's not shown on this screenshot, but there is one field here, which is the EMCC device level calling search space. Extension mobility does not update the device level calling search space when you do a login. EMCC doesn't have a phone where it applies your profile. There is no physical phone where it's applied to at the home cluster. There are just those dummy devices, and the configuration will be built from there. And when you create the dummy device, you do not set the device level calling search space there, so it's set at the profile here. That's how your phone record that is created at the home cluster gets its device CSS. Then you add the lines as you want to do. So this is simply the logical configuration of that logged in user. Why do you have to subscribe to the EM service here as well? Otherwise you couldn't log out, right? That's one of the top mistakes in extension mobility. If you do not subscribe your device profile to the extension mobility service, once it got applied, you cannot log out anymore because that phone is not subscribed to extension mobility anymore because that was changed. So your device profile also needs to be subscribed to the EM service. You have the end user configuration where you refer to that device profile, and here is a checkbox, enable extension mobility cross cluster. So on a per user basis, you can say extension mobility is fine, but EMCC needs an extra permission. At the physical phone, you have to enable extension mobility. So at each phone where you want to allow logins, not only you have to subscribe to the service, you also have to enable the feature at the physical phone. And as mentioned, you also have to subscribe to the service, of course. Bulk certificate management. You configure your SFTP server, IP address, port, username, password, and the directory where you want to store the certificates. Then you export them. After you click export, you will see the content of that storage, which means you see all the certificates that are in that directory, and the consolidate button appears. So you do that at all the servers from where you need to export certificates. Once you're done, once all of them are shown in this directory, you click the consolidate button. And now you get a consolidated file that includes all of them, which is also in that directory. You see it here. There is a bulk file for Tomcat, for TFTP. And now you go back to each server to import all the certificates by clicking the import button. You can choose whether you want to import all types or just a specific type like KPF, Tomcat, TFTP. And afterwards, if you want to make sure that it worked fine, simply have a look at the certificate list and check whether all these certs are now trusted certs. Add a common device configuration. This is used to add the dummy devices. So you add a common device config, or you configure one, and you will refer to that common device configuration later on when you do the bulk insert of your dummy devices. You do an EMCC template configuration where you refer to that, to a device pool, to a zip profile, and to that common device configuration, also to a common phone profile. So this is really your EMCC config where you say, I want to add phones based on these templates. And you see you can select the device pool here. If you want to add dummy phones with multiple device pools, you can do that from here. But typically what you do is you would only have a single device pool here. And if you want to have different device pools on a per visiting cluster basis, you would simply use the geolocation feature, right? So you simply configure other device pools with geolocations, and then the device pool that you referred to here when you added the dummy record is anyway overwritten by the roaming device pool. So this device pool here is only used if no roaming device pool was found. Then you go to insert update EMCC configuration, and now you say I want to insert EMCC devices, that number, this is the template that I want to use that you just configured previously where you refer to all the other templates and the device pool, and then you submit the bulk job. So make sure that the batch service is up and running, otherwise that job never gets executed, right? So again, look at the result afterwards, whether this was successful. The number of dummy devices that you add specifies how many EMCC devices can be registered at the same time. You add a geolocation filter. The filter simply says these are the fields that are configurable geolocation items. Which ones do I want to consider when trying to match a roaming device pool? That's the filter. And actually, I didn't include the screenshots. At the phone itself, you would apply the geolocation. So you can set the geolocation on a per phone basis or by device pool. And at the roaming device pool, you would say this is the geolocation tag that I want to match when looking for the roaming device pool. Enterprise and feature parameters. So we have some additional parameters. One of them was whether you want to use the calling search space of the trunk or of the physical phone on inbound calls when you use the PSTN access feature. Others include the TFTP server for EMCC login devices. You can set one and a backup. Remember what I told you about the bulk certificate management? If you set 2 TFTP servers here, make sure that you export the certificate of both TFTP servers. How do you export certificates? Can you do that on a cluster basis? Can I go to the publisher's OS admin GUI and export the TFTP certificate of 2 servers? No. You have to go to the publisher and export, and then you go to the subscriber OS admin and you say, I want to export this server's TFTP certificate. Certificates are exported on a per server basis. That's not on a per cluster basis. In fact, everything you do at OS administration applies to this one server and not to all servers of the cluster. Okay, so the mandatory parameters that you have to set here is the default TFTP server, the geolocation filter. As mentioned, you have to have one, no matter whether you indeed use the geolocation filter, whether you will match something or not, but the filter has to be set. And the default server for remote cluster update. So this would be the server that interacts with the remote cluster on the communication between the 2 clusters. So the zip trunk, you add a zip trunk, and the trunk service type is EMCC. On that trunk, you do not configure a destination. No destination by IP address, fully qualified domain name, or SRV, DNS lookups. You simply don't configure a destination at all because this is really a kind of template. This trunk configuration will be used on dynamically created trunks when talking to another cluster. So how do we find out the IP address of the other cluster? We will see later on when you configure EMCC, you have to say, what are the other clusters that I want to do EMCC with? So the clusters are added and we know the IP address of the other clusters. It's not necessary to set it at the trunk. Okay. Then you go to the Advanced Features EMCC Intercluster Service Profile. Here you enable EMCC as such. You can selectively enable and disable PSTN access. And if you tick that box, then you have to select the EMCC trunk. Take care here. You know, sometimes the GUI doesn't really follow or reflect the requirements. EMCC does not work if you do not configure that trunk and if you do not check that box. Look at it from this perspective. This trunk configuration also represents the communication for the remote login and so on and so forth. Okay? So by ticking that box, it's not that you enable the PSTN access feature. I mean, in fact, you do, but it wouldn't work without. So you cannot disable PSTN access by unchecking this box. It has to be set. The way how you can do it is later on a per destination cluster basis. You can selectively enable and disable these 3 features, and there you can uncheck it. But here, in the global config, EMCC will not work unless you have a trunk and unless you configure the PSTN access. RSVP agent is different. That doesn't have to be set, and it would still work. So that's a global configuration, and then you can also set it on a per destination cluster basis. There is a validate button, and it will check your whole configuration. And you see it checks whether there is a geolocation filter. simply because it's mandatory, even if you won't use geolocation. Feature, which means your phones don't have a geolocation, you don't set geolocation tags at roaming device pools, the filter needs to be configured. And you also see that it asks for the PSTN access service. And if that is not a success, if it's not enabled, it won't work. Remote cluster configuration. So now you add the remote clusters by their name, by their IP address. And now per destination cluster, you can say what are the features that are allowed to be used. That's the standard functionality. This is to say if you match a pattern with ends up at the local route group, send it to the other cluster. And this would be RSVP agents. So here you can control what services do you want to provide to what cluster. At the previous slide, at the global config, tick it. Otherwise, it won't work. And yeah, you can, after you did that, you can say update remote cluster now so that the other cluster knows that you now allow that feature to be used. And you see also the status. That's it. Extension mobility cross clusters. I think it's a quite complex feature because you have to think a lot about especially the dial plan and the chunked CSS and how to use it. As mentioned several times, if you have a complex international deployment, go globalized. If you want to do call admission control, I assume you will prefer the LBM network more than using RSVP agents. So if you are on version 10, make sure that you use that feature. Any questions? Let's start here. Yeah, feel free.
So I don't know how much influence you have over roadmap, but I want to follow up on the questions you got earlier about directories and overlap of usernames. In the business cases that I have for EMCC, it's not two different companies or even two different directories. It's one company, one directory, and there are so many times that I'm splitting clusters either for scale or for complexity because I need to have a contact center cluster over here and I need to be able to roam back and forth. So we've been hacking around this, at least on CM9 forward, where we can have local users and we can fake one up, but of course we have some scale challenges. You know, there's stuff like me as an administrator, I need to be present on all the clusters, you know, to be able to log in as an admin to administer things, but then I can't have EM. There's a lot of places where this hurts. So I don't know how much influence you have on roadmap, but if I could ask for one thing, don't just search for existence of the user. Search for existence of the user plus they have an EM profile on that cluster or something. It would really, really help. Yep. It's the one thing it's missing to really make it work for all my customers.
Yeah, I totally agree. This is a limitation, and actually it's a popular request of those that use EMCC, considering that in most cases it is very large deployments. You use LDAP, but if it's all rooted in one LDAP directory, then you do have those problems, yes. So unfortunately, you know, I'm external. I'm not a Cisco employee. I mean, I do take it back, and people I talk to, they are aware of it, but I have absolutely no impact on the priorities on the roadmap. But I hear you. I will pass it along
in particular
again.
I should yell at?
Pardon me?
You know anybody I should yell at?
Actually, I may be able to help you. Yeah,
I'll catch up.
Okay. So that was a request, not really a question, right? But a wish for some improvements in the future in terms of finding the user or having the need to find that user at one home cluster. Any other questions? I guess there are lots of them, but you need to think about it, potentially play with it in lab, and then some more questions will pop up. If you're new to EMCC, then I guess this was dense, right? Lots of information in short time. So no questions at this point in time? Yes, there is one. Okay.
So the cross cluster, let's say you have an emergency call, and the cluster is serving not a country, but a continent.
Mm-hmm.
And maybe multiple continents. Let's say you have a UK as well as US server.
Mm-hmm. 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 Yeah.
But it's the same cluster.
Yeah. So let me repeat the question. I like the question a lot. So he's saying, what if my visiting cluster serves multiple countries, that have different emergency numbers. I can, at the home cluster, I can say, based on the visiting cluster, I modify your input. Let's say you dialed 112, 2999, or 2911, but that's based on the visiting cluster. But now the visiting cluster serves multiple countries. How can I deal with this? Because I cannot guess where you are or how to manipulate it. Well, you can, and you don't have to guess. If we think about the process, what happens? I receive, let's say the user input is 112, but I'm in the UK. Let's say that's the assumption. It goes to the home cluster. First thing, of course, you have to make sure that I'm ending up at the local route group. You send it over the trunk. I don't care what you do to the number now because there are different ways to do it. Let's say we leave it as is. We leave it at 112, right? It hits the visiting cluster. How is the egress gateway selected? That's the key point now. If this is a multi-site deployment, multiple countries, you need to know what gateway will be used by this visiting phone, which simply means what you have to make sure is that 112 matches a route pattern that refers to the local route group. Now the visiting cluster selects the egress gateway based on the local route group, so we know what the egress gateway is. The number wasn't modified, it's still 112. Let's assume the egress gateway is in the UK. At the egress gateway, you would do an outbound cold party transformation, CSS, where you say, if I see 112 or 911 or whatever, I change it to whatever is my local need. So you would do an additional step. When you are familiar with globalized call routing, the idea is that you change the number at the egress gateway to whatever your need is. In this case, what you should think of is, what do you want to send across the trunk? I would strictly recommend that you analyze your dial plan, and if you find any possible number that doesn't overlap with all the countries that you have, right? An example would be plus, and then a country code, which is reserved by the ITU, which is not in use. So you would say whatever an end user dials as an emergency number, 911, 112, 999, I don't care. I always globalize it to plus something which is not in use worldwide, right? That's the number that you put on the zip trunk. And then on the receiving cluster at all egress gateways, you say, if I see plus whatever that number is, I modify it to 112 if this is an Austrian gateway, I modify it to 999 if it's a UK gateway, 911 if it's a US gateway, and so on. Think globalized in your dial plan. Globalize everything you can, and to me that also means globalize your emergency number, because otherwise you run into that problem. What would be the problem? I mean, it also works without a globalized number, but what you would have to do, you would have to say, I may receive 112, I may receive 999, I may receive 911. Change all this localized input at ingress. Change it to one well-defined format as soon as possible, and then that's your friend. You have a single number you have to care about. I'm recommending this even in a non-EMCC environment. When you do globalized call routing, globalize your emergency number. Because otherwise you may have overlapping numbers, you run into issues with interdigit timeout and so on, overlapping patterns. This time you have one number which is globally unique, representing emergency dialing. You're welcome. Any other questions? Okay, thanks a lot. See you next